Okay, so if you remember right, we were talking yesterday about temperature, right? We talked about temperature yesterday. And we asked ourselves, which one of these would be colder? Would it be the ice cream or the tea? And what did we say?
Ice cream.
We said the ice cream would probably be colder, right?
Yeah.
Okay, so let me go back up here. So we said it'd be easy to tell if an object is hot or cold by touching it. But in science, you don't want to touch, you be very careful about what you touch, because it's either super cold or super hot, and it can literally burn you or freeze your skin, give you frostbite. So what you do, rather than touching something, you might just press it toward it, and you can kind of feel the heat or the coldness, right?
Yep.
Okay. And how hot or cold something feels is related to its temperature. Okay, but it only provides a rough indicator. We'll talk more about that later. And we also said that to understand temperature, we have to remember that all matter is made up of molecules that are in constant motion. We said yesterday that even your tabletop there that's solid, those molecules are shivering. They're moving really slow, so slow we can't see them. Liquid, they're moving a little faster. Solid, they're moving slower. Gas is when they're really excited and they're moving really fast, far apart. The colder they are, the closer they get, the hotter they are,
Well, they had the keyboard.
the faster they move, and the farther they move apart.
They have,
They keep moving, yes. You remember we watched this yesterday? Depending on cold, hot. Which one's moving faster, hot or cold?
Hot.
Hot's moving faster, you got the idea. Okay, so we talked about that yesterday. And that is called thermal expansion when as the temperature increases, the molecules pick up speed and they gain something called kinetic energy. And kinetic energy causes the molecules to spread farther apart. Okay? The more kinetic energy something has, the faster it moves, and the faster it moves and the farther apart it moves. Up to and including gas, which just it goes everywhere, doesn't it? It just floats in the air. Okay? Okay. So we went through the questions. And we'll talk about this at another time. Okay, today we're going to talk about thermal expansion, or thermal energy, I'm sorry. So this is what I'm going to talk about today, thermal energy. Okay, so here we go. So, as we said yesterday and today, molecules in matter possess kinetic energy, right? In solids, it's it's less kinetic energy. They're moving slower. In something like gas or liquid, there's more kinetic energy. Okay, so why do they have kinetic energy? Well, look right here. Which drink is likely to have molecules with more kinetic energy? Is it going to be the iced?
Ice.
That looks like maybe limeade or something, or the hot coffee or tea. Which one's going to have more kinetic energy, based on what we just talked about? Say it.
D.
The tea or coffee, yes. It's going to have more because it's hotter, right? More kinetic energy. Okay. Okay, so look, so if the hotter an object is, the faster the molecules in it move. Is that a true statement or a false statement? Use your document there and mark your answer. Don't blurt out an answer, just mark your answer. You can use an X. You can use an X with the type, or you can draw, circle. Okay, everybody got an answer?
No.
Whether that's true or false. Use the drawing tool or the typing tool. There's also what's called a markup tool that'll highlight it. That works too. That'll work as well. Are you okay, Richard? Okay. Okay, everybody there?
No.
Okay, I'm gonna give you 2 more seconds and I'm moving on. Okay. Okay, so let's look right here. Let's look at energy in matter. Now, what do we say matter is? anything that has mass and takes up space, everything in the world is made up of matter, right? We said that the other day when we were doing, I think we did a preview of what matter is. And we said matter is anything that has mass and takes up space, and everything in the world has matter, okay? So molecules in matter also, not only do they have kinetic energy, which makes them move faster, the more kinetic energy they have, makes them move faster and farther apart, but also, all matter has potential energy. Now what's potential energy? Well, let's find out here. So this energy is based on the attractive and repelling forces that all molecules exert on each other, okay? So, and molecules are made up of individual atoms, right? Molecules made up of individual atoms, and each atom contains a positively charged nucleus and negatively charged electron outside the nucleus. Look right here, inside here's a proton, right? That's, what kind of sign does that have? A plus sign, right? Okay. Now, look at the blue, has that got a sign? No, that's called a neutron. And then you have something called an electron that has a negative sign, right? Okay. Now, if you have a positive, look at this magnet right here. What do you got here? Blue and red, are they the same or are they opposite? Are they the same colors or are they opposite colors?
Opposite.
Different colors, right? Opposite colors. Okay, so what happens when I move, here's an opposite,
They're
the
gonna
opposites,
stick.
opposites actually attract, that's a scientific
When
law,
you stick
opposites
blue to
attract.
blue, it won't stick.
How about blue and blue, what happens?
It won't stick.
Okay, so they repel each other, right? They're the same, so they repel each other. Okay, so that's the way protons and electrons are. Protons have a positive, electrons have a negative, so what do? They attract each other. Okay, they attract. Got the idea? They're attracting. Okay, so so this potential energy is based on attractive and repelling forces that all molecules exert on each other. And that's because each one of those molecules is made up of atoms, and each of those atoms have that positively charged nucleus. That's what this is, positively charged. And then it's got these negative electrons on the outside. Okay, this is in every atom. And you remember how many atoms there are with a pencil mark? 40 billion atoms that all have these same characteristics here, okay? Okay, so let's move on. Here's another question. Protons and electrons, look here, what is this? A positive, right? P for positive protons. And then electrons are what? Negative. Okay, so protons and electrons, do they attract each other? Protons and electrons, they're opposite, do they attract or do they repel? What do? Do they attract each other or do they repel each other? You can't choose C. And you at home, you can pause the video and answer your question before it,
Before you're gone.
okay? Everybody got an answer? You got an answer there, Jaden? Give me an answer. Jaden? Okay, put that around your neck. Put that around your neck. Put it around your neck. I'm gonna ask you to leave. I'm gonna ask you to go across the hall here if you can't put that around your neck. Okay, so everybody got an answer here, right? Okay, so let's answer this question here, 11. Okay, so opposite charges attract. You remember this? Look here, opposite charges attract. Here's red and blue. They attract. How about like charges? What do? This is red and red. Well, do these attract? They won't attract, will they? let's try the blue side. Both are blue, will they attract? Okay, that's fine. Okay, so opposite charges, do they attract or they repel? Mark your answer, A or B. Put that around your neck. Okay. Everybody got an answer? I'm gonna move on. Okay, so, let's look at energy in matter. Let's look a little bit at energy in matter. Okay? Okay, so, when atoms and molecules interact, electrons are attracted to protons, right? And that's just, what we just said here. Let's say this red is an electron, let's say the blue is a proton, and they attract each other, right? Okay, so they attract to protons and they're repelled by other electrons. So let's say the blue is the electron, and you cannot put them together where they'll stay. They repel each other, right? Okay, so atoms in a molecule are bonded. So when they're like this, they're bonded together, right? They're bonded, they stay together. They're bonded together because they're positively charged nuclei. And you remember what that positively charged nuclei looks like? This inside here, this is positively charged. That's the nucleus or nuclei. So atoms in the molecule are bonded together because they're positively charged nuclei and negatively charged electrons. Look right here. Remember this? The electrons are right here and they're negative. Positive inside the nucleus. Negative on the outside with the electrons. So their negatively charged electrons are attracted to each other. Okay, the positively charged nuclei and the negatively charged electrons attract each other. Okay, so look right here. So repelling forces between electrons and electrons, look what they do. They move away from each other, right? They want to move away. Blue to blue, they want to move away, right?
You need to stop now.
Can I ask you to just walk him across there, have Miss Shipley come and get him? Okay. I just asked Miss Shipley to come get him. Okay, so. You're gonna leave it to Paul after, let Paul after that. Okay, so let's move on here. So repelling forces, that's the two blues, they won't attract. Between electrons and electrons, right? Attractive forces between positive and negative charges. Red, blue, positive, negative, okay? Got the idea? Okay, so let's look right here. So we're still talking about energy and matter. So as the distance between atoms and molecules increases, the forces of attraction and repulse decrease, okay? And the potential energy does what? Look here. They're repelling each other. They're repelling each other. Look at here. You got two blues. Are they gonna repel or attract? They're gonna repel, right? Okay, but look here. The farther they go away from each other, the less you can feel the magnetism. The closer they get, you can feel that they're repelling. The farther away they go, there's less. The force of attraction decreases. Okay, same way here. We can do it this way too. Look here, I'm gonna pull them apart. They're together, right? I can pull them apart. Oh, I can feel the attraction even out here. But the farther apart I go, I feel less attraction. Okay, got the idea? Okay. Okay, so look right here. So the electrical potential energy is inversely, that means it's, well, we'll talk about it. Inversely proportional to the distance between molecules in matter. So what does this inversely proportional relationship mean? Look right here. Okay, look. the closer the molecules are together, the more potential energy they have. That's what inversely means. The farther apart molecules are, the less potential energy they possess. Okay? Got the idea? Okay. You know what I want you to do? I want you to use your markup tool. Highlight this right here. Did your box have that open? Does your box have that verbiage in here? Or is it a blank box? It's a blank box? Okay. Okay, well, you won't be able to highlight that then. Okay, that's fine. You can see it in, you can see it in the video presentation for those of you at home, okay? Okay, so look right here. We're still talking about energy and matter. Are you with me? Okay. Okay, so let's look right here. I see a gas, I see a liquid, and I see a solid. I see a gas. Look how far apart they are. I see a liquid. They're kind of apart, but they're not anywhere near as close as this solid here, right? So can you rank the amount of stored potential energy in each state of matter from the highest to the lowest? Which do you think would have the most energy? Anybody have an idea? Tyler? Which one of these would probably have the most energy?
Gas.
Okay, this would have the most energy. Which would probably have the least?
Liquid has the most.
Which is the closest? Sarah, which is the closest? Which of the molecules are the closest? Solid, liquid? Gas is the farthest apart, so it's gonna have the most energy, right? Think of boiling water and the steam going up, those molecules are just going everywhere, right? A lot of energy. Liquid, think of what's in the bottle here. It's just kinda there, hanging around the shape of the bottle. And then you got solid, which, if that were frozen, it wouldn't be doing anything, right? It'd be there just shivering. Okay, so let's take a look right here. Okay, from the highest to the low, I'm sorry, we're gonna go from, this is potential energy from the highest to the lowest, okay? So highest potential energy would be solid. That's the most kinetic energy. Right, got the idea? The most kinetic energy would be the least potential energy. So solid would be the most potential, liquid would be in the middle, and gas would be, the total least potential. Okay? Okay, let's answer this question right here. Okay, there's two answers to this. Two answers to this question here. There's two answers to this question. You're gonna mark two answers. So what two types of energy do molecules possess in matter? What two types of energy do molecules in matter possess? Is it potential energy, kinetic energy, gravity, or thermal energy? There's two of those that are correct. And we just talked about both of them. We used both words. Did we use potential, kinetic, gravity, or thermal? Which of those two words did we just use? Mark two answers. Everybody got answers? You got an answer, Lexi? Good, okay. Okay, here's another question. Oh my. Okay. So what type of energy describes the motion of molecules in matter? If it's motion, do you think of kinetic energy or potential energy? If it's motion. Kinetic or potential? Is it kinetic energy or potential energy when you think of energy of motion? Okay. Everybody got an answer? Are you getting an answer? You getting answers there, Richard? Tyler,
I
you got it?
will.
You got an answer? Good job. Okay, so, potential energy. This is found in matter based on what? Is it based on, let me see your choices here. You guys are sixth graders. Is it based on attraction or repulsion? You can't choose D or A. Is it based on attraction or repulsion? Potential energy, okay? Remember, it's the opposite of kinetic energy. So would it be attraction or repulsion, B or C? You can't choose A or D. It's okay to be wrong, it's not the end of the world. We'll talk more about it later, so don't be afraid to answer. It's okay to be wrong. Okay, we'll talk more about all this as we go through the lesson here. Okay, this is just to see what you've learned here based on what Mr. Hughes just told you. Are you ready? Everybody got an answer? It's either B or C, attraction or repulsion. Potential energy found in matter is based on the what? Attraction or repulsion between the molecules and matter. We'll go back over that in a second. Okay? And I want to show you something here. So if you add, because matter has kinetic and potential energy, right? This is basically what this is telling you here. So the total kinetic and potential energy associated with all molecules in a substance is called thermal energy, okay? Kinetic energy plus the potential energy is called thermal energy. Okay, and some people call it the total molecular energy. All I really want you to understand that it's thermal energy, okay? That's what I want you to understand. So thermal energy and, listen, thermal energy and temperature are different. They're not the same. They're not the same because temperature only considers the average kinetic energy, okay? And thermal energy adds both of them. We'll talk more about that. It'll become more clear to you. And I'm kind of thinking that might be where we're going to stop here. We're going to stop there. We're going to stop there for the day. We're going to talk about thermal energy versus temperature tomorrow, okay? We're going to stop right there.